Welcome to Emerald Hill Skies. My name is Doug, and we're coming to you tonight from the outskirts of Louisville, Kentucky. We are happy to be here on a moonless, inky black night in December. It's nice and cold out there. The temperature is around 31 degrees. Even the spout from the dehumidifier out of the observatory was frozen over tonight. So the humidity inside the observatory was up to about 70%. So I have to figure out later, how do you defrost the drain from the dehumidifier? These are like first world problems, right? But welcome. We're glad you're here. I was just looking at the stream. We've got several people who've logged on. Tiffany, of course, thanks being the hostess. Let me know if you can hear this audio. I'm using a different audio setup tonight. And let me know if the balance is right between the music and the voice. I never know what to do with that. Ray, good to have you on from Arizona. I bet it's warmer in Arizona. Surely, I hope so. Jesse, good to have you aboard. Let's see. It sounds like you're a little bit cold out there in Arizona after all, Ray. I didn't realize that. Dennis, good to have you aboard from Colorado. Haven't seen you in a while. And Jesse, sorry about those clouds in Seattle. I don't know why, but it's just the stereotype that we thought it would be there, those clouds. John, good to have you aboard from New Mexico. And wow, Dennis, thanks for that encouragement about the audio. Please, somebody speak up and let me know if things get haywire, if you can't hear well enough. Now I can control the volume a little more, what would you call it? Granularly, I guess I could say. We are looking forward also tonight to utilizing a different approach for keeping track of our targets. And I don't know if it's going to work or not. Let's just see, first of all, what the scope looks like out there. It is moonless, but remember, the camera that's in the observatory now that we call the scope cam, that's like a night vision security camera device that's really got a wide open aperture, so you can see it's looking pretty broad daylight out there. The sky is just looking great. It's incredibly clear and just a stereotypical December cold, crisp cold night. The new program we're using for targeting is called Astro-Planner. You know, actually about a year and a half ago I was using Astro-Planner. And I don't know why I just fell out of love with it. I don't know. The screen's a little bit bright, and I don't really know how to find on it a darker color like the targeting software I was using. However, recently I've just really come to appreciate how powerful it is. So we're going to try it tonight. It's completely first time breaking out of the box again. And I don't know if I've got this list typed in there. I had to retype the entire Cosmic Challenge list into it by hand for the most part. So we'll see if it'll even work. It looks like it's connected to the telescope, but I don't know how that's going to work either. And I can't get the sorting figured out. Maybe before it's over, you guys can help me figure out how to sort the objects correctly, because so far I couldn't get all that sorted out. And then we'll be using the same as before, using SharpCap. This is the view of the North Star there. There's Polaris, so that's where we've just basically turned on the camera and let it sit there for a minute while we've been getting going. So let's just try getting to our first target. How about that? The first set of targets that we have, at least as far as I can tell, boy, the sort just does not look right. Help me think this through, guys. Would we not want to sort it by, first of all, by visibility? So that's just going to put all the ones that are visible at the top. And I've got that turned so that it's descending. So if the visibility says yes, then it sorts those first at the top. Then wouldn't the next thing be the altitude? Is that right? So it seems like that would, let me just say altitude in ascending order. What does that look like? See, it doesn't even look like it's sorting out. What am I doing wrong? Sort list. And here's the altitude column. Now let me make sure that there's nothing strange about that. Yeah, there's the altitude column. I mean, here are some that are 49 degrees, but here's a 39. So there's something weird about that. But let's just get started because I'm just going to pick one. Here is an object that's at 50 degrees. So let's just start there. And let's go ahead. I'm going to try now to slew to the object. And let's look at our scope and see if it's moving. It is moving. So, folks, we have liftoff here. So that means the targeting software is controlling the mount. So that's a good sign. It linked with the telescope and is controlling the mount. And the name of our first target is Hipparchus 677. It's object number 10 in the list. So I'm going to type in Hipparchus 677 and the title. Now let's go over to the screen so you can see what I'm looking at there. And I bet that's our star. Let's go ahead and do, let's see, connect the mount in SharpCap. And let's do a plate solve in SharpCap so that it will tune the mount and make sure we're pointed at what we're supposed to be pointing at. While it's doing that, let's turn in our book to Cosmic Challenge Object 10, and let's see what we're supposed to be looking at here. This is in the Great Square of Pegasus, and the first target is Hipparchus 677, which is, make a little more room here in our, the star is called Syrah. Que sera, sera. You know, Thicam, you ask about Betelgeuse. I don't think that, what would you call it, like that asteroid that's eclipsing Betelgeuse, I don't think that's happening in our latitude. It's just happening between like a latitude and Florida. Pretty narrow, Mexico to Florida. And that's it. So unfortunately, we'll have to look at that, you know, via the YouTube videos, sadly. Okay, so it has found, so to speak, that there's a match between what it expected to find and our real sky. And it's now plate solved. So it's put this star, Hipparchus 677, in the right place. Now what this is supposed to be is a double star, and I guess let's read about what Phil Harrington says. Pegasus is one of the best known autumn constellations. Oh, he's just basically showing us Pegasus. So let's switch to our sky view, and let's see in our sky view if we can see what he's talking about. Oh yeah, here's the Great Square of Pegasus right here. Can you guys see my pointer, by the way? I don't know if you're... Yep, Tiffany, that's it. What will be, will be. This is the Great Square of Pegasus, and that's the way it is with the Cosmic Challenge. He gives you different levels of challenge, and this one's called a Naked Eye Challenge. So let's go over in Stellarium, which is our planetarium software. Now, so far, I don't know how to synchronize this with Astro Planner. I'm sure there is a way to do that. But let's use this star number, Hipparchus 677 in Stellarium. Let's get back to Stellarium here. Hipparchus 677. And so there is the Great Square of Pegasus. It's kind of back off so you can kind of see. So if you go out tonight or some other night like this and look due west, maybe you'll see a giant square up in the sky. And that giant square is the Great Square of Pegasus. It should just be right over the western horizon, due west. And the star that's highest in the night sky is the one we're looking at right now. It's Alpheratz. It has a couple different names. And the Syrah is one name, and then let's go down here. Alpheratz is the other name. You can see here in the observing the name notes. Okay, so what we're doing here in this first target, naked eye visibility, is we're just looking at these 4 stars that make up the Great Square of Pegasus. And we can do that, again, by going to our sky view here. And here are the 4 stars. And Alpheratz is this one that's tallest. Okay, so what we're going to do is we're just going to basically make this quick observation. I think it's just going to take care of that one for us. And then the second star we're looking at is Algenib, and that's this one here on the left. So let's go back here in our sky view, and you can see Alpheratz and Algenib, and we'll do a quick observation of that. And then the third star we're looking at is called Sheat, and Sheat is the one right here on the right hand side on the bottom, and we'll do a quick observation there. And then the fourth star is called Markab, and it's the one that's on the lower left. So let's see how well we can remember those. This one was Alpheratz, that's Algenib, that one was Sheat, and that's Markab. So now you can identify the Great Square of Pegasus at night, and that's really, I think, all that Harrington says. He says, depending on the darkness and transparency of your observing site, you may be able to see the full complement of players on our cosmic ball field, or possibly just the 4 bases. So he's saying that makes like a ball diamond. And you can see where we are. There is a lot of sky glow there at the bottom of that scene of the sky cam. But even though there's a lot of light, our sky cam is picking out more players. And let's do some zooming in here, just so we can see. Notice how we're seeing not only these 4 stars here, but we're also seeing a collection of stars down here in the lower left. Right here it is. This represents this Pisces constellation. And you can see this little circle here, and a lot of, here's that little circle, and then this trail starts going straight up of those stars there. It's pretty awesome, isn't it, to be able to do this from inside out of the 31-degree cold. There goes that line up, and then it's going to go a line over to a little triangle. Let's see how many of those we can make out. Let's go to the sky view, and let's back off now. So there's that little circle, and here's the line that goes up, and then there's the line that goes over. And let's see how many stars. From the corner, you've got 1, 2, 3, 4, 5, 6 until we see a little bright one. So let's look here. 1, 2, 3, 4, and then that bright one is Meroc, which is back in the constellation of Pegasus again. So we don't want to go quite as far as Meroc. We want to stop right before it. Let's go back. So here is that. Let's get our great square again. Here's the great square. And then here's that circle. Here's the line that goes up. And here's the line that goes over. 1, 2, 3, 4, 5. Now there's that little triangle that makes up the last of Pisces. How are we doing on that? You guys making that out? It's awesome. All right, so Phil Harrington, thanks for bringing us to this. Did we do a quick observation of this one? Here's our observation column. Now notice, once we do the observation, it puts a black, like a gray box in here. So let's do this and you'll see that color in. Now there's that box and it's got the number 1 in it. And what that means is we've done these 4 observations tonight. So it's showing us what those observations are. All right, now let's go to a step, maybe a step more complicated. Let's go to something maybe that's set up for a, see, it looks like we've already observed this before. And now I've got all the objects in that group listed. See how there are 3 different galaxies here. And the way I've typed them into AstroPlanner, they are all there now. I wonder what this is. This is, this must be, this is object number 5. This must be stars in a Little Dipper. Let's just go there while we're at it. Okay, so we're going to go here to back to where we were. And we'll say you can either use this slew to object, or there's another slew to object that you can use up here at the top. And now it's got a nice little green bar graph on the, by the way, here's a cool view of all the stars skimming by when you are slewing. And then look how it gives the bar graph to show us that it's done. So I like that. And now we're back looking at the Little Dipper, and let's see if we can find it here. Pretty hard to see. Let's go here in Stellarium, and let's go to Polaris right there. Okay, so the Little Dipper is pointing down, and the bowl is sort of aimed up toward the northeast. Again, for orientation's sake, obviously Polaris is the North Star, closest thing we have to the actual celestial North Pole. And look how it's aimed over here toward the northeast. So if you go out tonight or tomorrow night or whenever you have some clear sky next time, then you can look and see if you can find the North Star at the end of this dipper. Now let's see if we can go into the, first of all, to the, yeah, we went right to the North Star. Let's go ahead and do our, well, we won't do a plate solve here because sometimes it doesn't work for me right at the North Pole. So let's go back to the sky cam again. And my goodness, that must be an airplane, right? Yeah. So help us get our bearings here. Maybe it's because the telescope, look how the telescope is over on its side. So we're going to have to kind of turn our heads. Because look, this is the ground. Down here at the bottom, let's go to our sky cam. This is the ground down here. So if we're going to find Little Dipper, somebody help us find it. Are you guys seeing it? Yeah, it is a nifty program, AstroPlanner. I'm kind of turning my head on its side here, trying to find in our collection of stars there where the Little Dipper is. Anybody seeing it? We should be aimed right at it right here. Let's see. Let's go back to Stellarium, get our bearings. Okay, back to the sky view. Not very handy to be on our side like this. Wonder if I can turn that somehow. Anybody remember how I can rotate that? Miscellaneous controls, maybe? No. Image controls, no. Here we go. Flip. Oh boy, I'm going to get it all mixed up here, aren't I? Maybe there isn't a rotate. I can flip it horizontally. That's not going to help us. And I can flip it vertically, but I can't just rotate it. Oh, Dennis has spotted it. He says it's lower left. See if you can find a little dipper here with us. Dennis says it's lower left. Boy, we need you to point it out for us, Dennis. Because I'm supposed to be the amateur astronomer. Oh, wait, here's the Big Dipper. Look, there's the Big Dipper up there. So if you follow the pointer stars, that should be the North Star. Ah, here we go. So there's the North Star, right in the middle. And there's the first handle star. There's the second. And that's the first. The North Star is the first. There's the second. There's the third. And there's the fourth handle star. And then this starts the dipper. Can you guys see the pointer when I'm gesturing to the pointer? Yes, I think you can. Okay, so here's the one. Now, I got to tell you, it is lost a bit in all that light pollution, isn't it? All this light pollution down here, which is Louisville, it's lost. But the way I found it was by going to the Big Dipper, and I saw the Big Dipper, it stood out, and then I saw those pointer stars, and they point right at the Little Dipper. So we've observed all of them now, so I'm going to go back here, and I'm going to say, quick observation there, quick observation there. Now, I do like Astro Planner for this. It is a lot faster, isn't it, than the way we used to have to do the observations in Deep Sky Planner. We're just like clicking these off like you would in a to-do list program now. Check, 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 check. Okay, so those were, did I get them all? I think for some reason I missed this. And I missed this. So I like that quick observation button. And you know who got me going? I just got to give credit where credit's due. A friend that we have over in the Isle of Wight, off the coast of England, there in the UK, the Isle of Wight, a friend named Pete, who has a nice channel there. He and I become friends, and he uses Astro Planner, and boy, I began to see how it was maybe a little more powerful than what I'd given credit for. Look how we can associate these objects together into one batch, and I really like that, and it helps them to sort together in the sort, I think, from what I'm seeing so far. But we're still brand new at this again. I mean, this is the first time we've used Astro Planner. This is live TV, so you're seeing this. And you're right, Jesse. The dippers always pour into one another. The Little Dipper pours in the Big Dipper, or vice versa. So, Papa Tech, good to have you aboard. And you must have warmer temperatures down there than we have. It's down to 31 degrees here. All right, let's head to the next item, which is a set of 3 galaxies. And it's NGC 3077. And these galaxies are in Ursa Major, so it shouldn't be a very far slew. This time I'm going to use this button up here at the top. There's a button right here I see that says slew to the object. This time I'm going to let you guys watch that, because it sort of makes a green bar graph to show the progress of the slew. So let's watch that for a second. There's that green bar graph, and see how it shows how quickly the slew is going. And when that bar graph comes clear across, then the movement of the scope will be done. I like that, because you kind of get a picture of what's going on there, and now it shows where our last slew pointed to, and it actually says up there, I don't know if you can read the fine print, it says the last slew pointed at NGC 3077. That's handy too. Remember in the times past, we would sometimes be forgetting whether we slewed the object, whether we moved the object yet. So I like that. All right, so that's our sky view. Let's bid goodbye to our sky view and let's head over to Sharp Cap again. And let's do, I already see a galaxy right here. Look at that. Let's do a plate solve. And while that's plate solving, let's go over to Stellarium and look at this galaxy. Now again, you know, I haven't figured out yet how to synchronize Stellarium with the Astroplaner yet. I couldn't get it figured out. So this is NGC 3077. So I'm having to put this in manually. And right there's where we are in the sky. So you see we're at northeast. So above the start of the cup of the Big Dipper. So let's zoom in here and let's look at these three galaxies together. This is the Garland Galaxy, and it's right there with, I guess, are these the three we're going to see? Bode's and Cigar Galaxy. If you saw some movement there, that was the indicator for the telescope as it plate solved. And it was just kind of indicating I'm zeroing in on the Garland Galaxy. Are those the three galaxies, or are there tighter galaxies here? Let's do this. Let's go back and look. NGC 2959. Okay, so back here, Bode's Galaxy is not. So there must be three galaxies in this group. Ah, you know what? I'm seeing something weird out here. I wonder if... No. This just must be the picture of the Garland Galaxy, but Stellarium's not showing anything any closer. Let's get our field of view. Boy, I just wonder if NGC 2959. I tell you what, let's search for that real quick. NGC 2959. Ah, it's farther away than Bode's. And then there is 2976. I wonder if that's the third one. It is. So the three galaxies he has looking at are close, but they're not exactly in the same field of view. Right now we're here at the Garland Galaxy, it's nicknamed. It's NGC 3077. And let's go now back to our actual let's start with our sequencer. Don't I have a program? Don't we have a program that says next prep for imaging only, I think it's called. And I think that stays aimed. Yes. And it just gets plate solving running. It just gets the live stacking running without the plate solving. And it changes the exposure to 20-second exposures, and it drops the gain down to 100. So it's a pretty handy setting if you're already pointing at the star. And as soon as that gets out of our way, we'll see our first exposure that comes up here. And right away I can see that our black level needs to be brought back down to right there. And then our mids can be brought up some. And then let's zoom in. Now there's that galaxy that we're viewing, and this is again 3077. I wonder if we can change NGC 3077. So right now that galaxy's not incredibly visible to us, but we're only at 60 seconds. Let's kick up the mids a little more. This does not look like so far a spiral, does it? Let's go to this object in Harrington's book, and this is supposed to be object number 47. 47. NGC 3077. You know what he says here is that because everybody in this part of the sky goes and looks at the Cigar Galaxy and Bode's Galaxy, he says these always get overlooked. And that's why he has us looking at these fainter objects. Messier never found them. 2 decades passed before William Herschel finally found them. 3077 is an odd-looking 10th magnitude elliptical. And sure enough, that's what we were observing in our live view. Right here's our live view. This is not a spiral, it's just elliptical. And what elliptical means, thanks for reminding me, Ray. Let's see if this gets a better... I'm not sure we improved things that much, but we're only at 3 minutes. So let's assume that after say 4 or 5 minutes, it's just an odd looking galaxy, isn't it? It's not really very distinct. It looks like there's a little bit going on out here, doesn't it? A little kind of tail or something. He says 3077 is an odd-looking 10th magnitude elliptical galaxy. It's the brighter of the two. He tells you where to look for it. He says it's like a round, fuzzy patch of gray light that is best described as featureless. Yeah, that's what we're seeing. He says, look carefully, though, and you should spot a faint stellar nucleus just peeking out at the galaxy's center. And he says long exposure photographs show several opaque dust clouds along the edge of the galaxy that radiate away from the galaxy's core like spokes on a bicycle wheel. Now, we were starting to see those after 4 minutes. He says elliptical galaxies are typically void of nebulosity, but NGC 3077's unusual appearance is probably due to its gravitational interplay with M81. Evidence of this is clearly visible in radio images, which reveal long filamentary threads of gas swirling between the two. So I don't know if we caught... Okay, so... I don't know if we caught... Let's back out to full frame. Oh, yeah. So what he's saying here is that Bode's galaxy here, remember back in Stellarium, this is Bode's galaxy, right on the corner of our field of view. Bode's galaxy, otherwise known as M81. And he says in radio telescopes, there are filaments that interact between these two. Now, odds are, if you've gone to these in your 6-inch scope, maybe you focused on M81 and its companion galaxy right here, which is a cigar galaxy M82. And maybe you've looked at M81 and 82. They kind of look like two eyeballs, don't they? Kind of like headlights. But what Phil Harrington's pointing out is you might never have taken the time to search out NGC 3077. Now we're at 150. Now that's 200%. But like I say, we could tell that there is an odd, kind of a shadowy extension here that almost looks like a tail of gas is spewing up out of this galaxy. And then you can also see here a much wider, darker spot, and gas is emanating from the whole thing. Let me just light it up a little bit more for a second with the mids, even though it's going to show all that confetti looking grain, the noise, the light noise in the sky. Okay, so that's 3077. We're going to snap a picture of this because I don't know if we've ever seen 3077 before, and certainly we haven't seen it before with a view toward looking at M81 and M82 in the same frame. So this will be a nice memory of these two galaxies. Now, let's go to the next target, which is, let's see if we can get 2976 and 2959 in the same target, the same field of view, sorry. 2959 is where we're going. So maybe you saw the little RASA crosshair coming across the screen there. And that'll be 2959, and hopefully over here to the side we'll also see 2976. Dennis is being very kind. He's saying, don't forget to hit the like button if you like content like this. Dennis, I always forget that, and thanks for pointing that out. All right, so let's go back to our live view, and we're going to put in the NGC 29, was it 76? Is that right? No, 2959. 2959. And the mount settled, so it's going to do its normal plate soft thing, even though it doesn't have to. But we've done our observation here in Garland. I think here in Garland, maybe we didn't do an observation. Let's do one of these kinds of observations, and let's try this for a second while that's plate solving. And let's see what we're supposed to do. I guess our observation notes are supposed to be right here. Now this does take a minute to arrange all these boxes. Huh. Observation notes, object notes, user notes. How does this work, pray tell? Oh, we have to hit a plus sign. There we go. And now we can say, after just 4 minutes, we could make out some darker patches and some, what would you call that, lighter filaments extending out from the, we'll just call it the northeast corner of NGC 3077. Otherwise, it was fairly void. Now, do we have to save that or anything, or is it automatically saved? Please tell me. I don't see a save button. Well, we're going to assume that it saves it without pressing a button, because I do not see one. So we're still on 3077 here. Now we're coming to 2959. I'm just going to go back to 3077 and see if that's saved. Yeah, it did. By the way, you might be wondering, when you change targeting programs like this, what happens to all the older observations from your previous software? Well, I did the best I could exporting them as a CSV, but then I tried to import them into Astro Planner, and man, I just could not sort it out. And so I contacted the developer of Astro Planner. His name is Paul Rodman. Nice guy. And he said, yeah, you're right. It doesn't import directly. You can't just take a CSV from something like Astro Planner and import it directly. But he said, look, you're probably not the only one that's ever going to do that. Let me just write a new feature in Astro Planner that will allow people that are coming from Deep Sky Planner 8 that'll import their observations, because I had like 1,200 observations in that year and a half, and I didn't want to have to hand key them in, copy and paste them all in one at a time if I didn't have to. And he said, no, you don't want to do that. Let me write something. And he wrote me a day or so ago and said, it's done. I just need to now make sure that it's ready to release to the public, and then it'll come out as a real live version update. So it's kind of nice, isn't it, that he's doing this for us, and then we'll be able to import all those observations. But these new observations we're making won't be lost. It'll just, those new ones will come in alongside of all these. So that's kind of fun. Right here in the middle is where 2959 is, but wow, isn't it small? Look at that. You can just see it as a smudge. Now, I'll tell you what, even though we've only been on this object for 3 minutes, look how you can see two distinct smudges. I don't know if you guys can see that. And look in Stellarium, if we zoom in on 2959, sure enough, there's a 2959 and a 2961 here, which is not a part of the plan here. So what we can do is go back here and just add NGC 2961. And sure enough, it tells us that it's found it. And then we can point it out that we observed that too. But we're going to leave it unnumbered because it's not a part of this set that we're observing right now, which is 2959, sorry. 2959 right here. Now, these smudges are pretty small, aren't they? Let's go back to the real-time view. This is the real-time view. we're at 277% of our RASA's teamed up capability with its ASI2600MC Pro camera. That's that ZWO color camera that's on the front end of the RASA there. With that combination of that 2600 and the RASA 11, these look pretty tiny, don't they? Let's see what Harrington says about them. 2959. He says, boy, I'm just not finding anything. 2959 is his object 47A. Both 2976 and 3077 can be spotted through small backyard telescopes given good skies. So he talks about 3077. And then he says 2976 is set about, he tells how to find it. He says 2976, which is over here. So there's 2976. Now there's a little bit more to write home about with this, huh? This looks like a hot pixel here, doesn't it? A hot pixel is an effect, you know, an artifact of the camera. Let's make sure that our hot pixel removal is on, but we might need to turn it up a little bit. Let's turn it up to maybe 7. Anyway, this galaxy has a little more structure. Look how we can see some stars out here in the outer patches of it. Now I'm zoomed in here at 560%. Yeah, Dennis is pointing out it's really small. And Tiffany's given praise to Paul for being willing to write up a new feature in the program to import our old observations from Deep Sky Planner. This almost looks like a star in one of the arms, and look how you can see after just 7 minutes some structure here in these arms. But what he says about 2976, he says it appears a little more than a dim oval glimmer through 3 to 5 inch telescopes, but it's riddled by gravitational warping caused by its proximity to M81. Although it's classified as a spiral galaxy, its nearly edge-on tilt to our line of sight, coupled with those distortions, blur its spiral arms in photographs. So in our 8-minute photograph, in our 8-minute visualization here, we're seeing that. But look, he's not saying anything about 2959. So I feel like he kind of like got our hopes up for 2959 here, and 2961. These are magnitude 14.7 and 12.7 respectively. So 2961 might as well say is 15th magnitude. So there's a 15th magnitude galaxy and there's a 13th magnitude galaxy. Pretty dim and pretty tiny. Wonder what the size is. Wow. So 58 arc seconds and 1.3 arc minutes. So this 2959 is 1.3 arc minutes in its smudge, and the width of this companion galaxy that we had to observe separately, which was 2961, the width of that is not even an arc minute. So we should kind of make a registration of that. If we go in at 440%, that's what an arc minute looks like. But you know, we're able to see that structure even though we're zoomed in. Dennis says he would love to see a web photo of this area. All right, let's go. I don't know if we can get a James Webb, but we should be able to get a Hubble, right? So we're going to look for 2959. Let's go out to here and look for Hubble 2959. NGC 2959. So here's the 2961 that we said was 1 arc minute wide. Actually, it was 57 arc seconds, so just under 1 arc minute. And this is about 1.1 arc minutes. A little more spiral structure there, huh? Let's go back to our real-time view. And let's pump up our mids. Yeah, we're just seeing hints, aren't we? Just a hint or two of that spiral structure. But we really have to strain. We're doing much better on this spiral here. 2961, whatever it was. Yeah, 2961. We're doing much better on it. You can tell it's a edge on spiral, and this is a face on spiral, but that's about it. All right, so let's just do a quick for 2959. Now, how do I do this again? A new I make sure that's highlighted, and then I say new observation, and then it does all this churning, and then I think I have to go plus. And then we're live, I think. Oh no, look. It actually created 2. It creates the first one when I went in. So let's delete this one. Let's go back to this one. So we don't have to hit the plus sign. It creates it for us when we go in. So let's say we could make out a hint of the arms and dust trails in this spiral face-on galaxy. And then for NGC 2976, now we have to use the plus sign, see, because yeah, that works pretty well. This was much more obvious to us. Now we're talking about now 2976. This was much more obvious to us. And this one we already did, I think, didn't we? 2961. I think we did a quick little observation of that. But what we're talking about now is this. You can see this thing that they sometimes call, haven't we seen astronomers call this flocking or something like that? This was much more obvious to us. We could make out the, whatever that's called, flocking, like cotton candy, whatever that noun is called. Like cotton candy in the outer arms. And several stars, presumably lighting up those arms. There's a little bit of lag with what I'm typing here. I type it and then it doesn't show up till later, just because of all the stuff we've got going here, you know, with the laptop streaming this to YouTube while we're doing these video streams. And also remember, we've still got the video stream running from the observatory of the scope and the Skycam, and our laptop is trying to balance all this at once. So there's a little bit of lag in the writing of these observations. Just one other thing I want to check, and that is if we go all the way here to the end to our new observation of 2961, what did it create? It's just an empty observation. So I can go back and add here. We could see the spiral nature of this galaxy, which is just under 1 arc minute wide. Ray says, don't forget. Oh, that this stretch down here you're talking about? You're saying we can use the display histogram stretch, Ray? Or were you saying these mids here? Because I think we've got them dialed up. Boy, this is a beautiful galaxy, isn't it? Even though it's tiny. Again, we're zoomed in at 325% here. But that is very beautiful, isn't it? Let's back off now and look at the big picture. It's really a cool shot of it there, just sort of hovering, you know, like this is a flying saucer on its way to visit 2959 here in the middle. It's just beautiful. All right. We hung out a bit, but we did 1, 2, 3 objects there at once. So let's go back to our list of objects here so we can see all the big picture. Oh, at the bottom of the page. Okay. Yeah, what do we call that? Should we call that the main histogram? Is that what that's called? Okay, so in terms of our objects now, you can see that the way this list works is I'm using the highlight to point out an object that we haven't seen yet. And once we've observed it, the moment we click observe, the highlight goes away. And notice over here, we've got these gray boxes with numbers in them, and the numbers inside are mostly ones. But there is a number 2 here. It shows us that we had observed the Garland galaxy before. We just hadn't observed its companions. So for our next object, let's go to M40. It's just at 18 degrees, but let's try it. So I'm just going to salute to it there. M40. And we have observed M40 before, but we have not, at least in our list here, it doesn't indicate that we have observed its companions. So let's check these out. And in Astro Planner, we're also looking for NGC 4290 and 4284. So let's first find M40. Now let me just hit right click on this. And there is a right click menu item called Center in Stellarium's Field of View. Now you would think Then when I click that, oh my goodness, look, it did. So it worked. Now the other night when I was trying this without the telescope, I don't think I got it to work, but it did tonight. So that's much handier. We can immediately, whoops, you weren't looking at that, were you? We can immediately zoom, it was just instant. We can instantly travel. Like here's where we were last time. And NGC 3077. So I'm going to say well, where is it now? I don't see the choice anymore. Right click. Oh, here we go. Show object. No. Center in Stellarium's field of view. So you can watch how this works. So when I click that, bam, it went to the Garland Galaxy. Now we're going to M40. So I'm clicking on that. And I'm going to say center in Stellarium's field of view. Now, interestingly, this is the last time we observed M40. Look how I drew an arrow to show where it was, because in the particular picture that we snagged, it doesn't even show up. The live stacking histogram. That's what it's called. Thank you, Ray. I can't see it because it's hidden behind the words at the bottom of the screen. Let's get rid of those words. Bam. Scope needs to be connected for it. Oh, so Ray is saying that you can't make it queue up Stellarium unless the scope is connected. How about that? Oh, or the camera. One or the other. Got it. So you're saying it works through ASCOM is what you're saying, I bet. That unless you do, if you don't have ASCOM working, then it can't function. And that's why I couldn't get it to work the other night. Thanks for that, Ray. Okay, so anyway, what we're looking at here is M40. What is M40 anyway? Just a... Is this one of those like... Is this one of those objects that Messier thought was a deep space object? And when years passed, it turned out to be just a double star. Is that what this is? Because this does not look like a deep sky object. Let's go to this in it's object 49 in Heritage list. And I bet he's going to remind us of this. Oh, here's what he writes. Most agree that the Messier catalog of deep sky objects stands as the finest compilation of star clusters, nebulae, and galaxies visible from the northern hemisphere. When it is time to single out the finest of the list's 109 entries, however, we often have trouble agreeing. Is it the Orion Nebula M42, the Great Globular Cluster M13, or maybe the Ring Nebula M57? One thing is for certain, you'll never find Messier's 40th entry on anyone's finest list. Now we know why. It's just a star. The rascal. We all make mistakes, Harrington writes, and M40 was one of Messier's. The story goes that Johann Hevelius, a noted observer from Danzig, Germany, reported seeing a nebula near the star Megrez, which is Delta Ursae Majoris, in 1660. 4 years later, try as he might, Messier could not repeat Hevelius' observation. All he found were a pair of close-set ninth magnitude stars. Messier noted on October 24th, I searched for the nebula above the tail of the Great Bear, which is indicated in Hevelius' book, Figure of the Stars, 2nd edition. I have found by means of this position 2 stars very near to each other and of equal brightness, about ninth magnitude, placed at the beginning of the tail of Ursa Major. One has difficulty to distinguish them with an ordinary refractor of 6 feet. There is reason to presume that Hevelius mistook these 2 stars for a nebula. For reasons lost to history, Messier decided to include the pair in his catalog, even though he knew well they were just 2 stars. Hevelius' legacy was resurrected again in 1863, when Frederick Winicki rediscovered the double star from Pulkovo Observatory in St. Petersburg, Russia. He marked down his position and, not knowing of the previous observations, subsequently included it as the 4th listing in his double star inventory. And sure enough, you can see here in Stellarium, in the upper left-hand corner, this star is called Winicki 4. And underneath Winicki 4 it says Messier 40. As a result, Messier 40 is often cross-listed with Winicki 4. More recent observations based on data from the European Space Agency's astrometric satellite Hipparcos suggests that the 2 components may actually be just an optical alignment, an optical double star, not really a true binary pair. Wow. So these objects aren't rotating around each other. They're just, by happenstance, they happen to be in our field of view as if they're a double. Call it M40 or Winicki 4 as you prefer. We're looking at a pair of stars shining at magnitudes 9.0 and 9.3, separated by about 50 arc seconds, slowly widening. Both are resolvable through giant binoculars, and Messier's description of the contrary offers little visual challenge for 3 to 5 inch apertures. Look for M40, although it leaves something to be desired. So let's go look at it now live. Setting these live stacking bars here. Boy, they do look just identical. You can see why. I guess you can see why somebody thought they were a double star, but why did Messier go on and list this as a beautiful object is the question of the day. But look over here to the left. Even look up here. I think those are galaxies. So there is something to be redeemed. This is a barred spiral. You can see the bar across it, and you can make out the spiral arms. And that's something. Let's go over to Stellarium and check this out. Uh-oh. Nothing in Stellarium about these. That's sad. Well, let's see what Harrington says. Although M40 leaves something to be desired, another object looms nearby that proves a worthy challenge for this size class instrument. NGC 4290, a small barred spiral galaxy, is just 11 arc minutes to the west. Says it's very difficult in suburban skies, but in darker sites you can make it out. If you can make out 4290, then try to find another even fainter galaxy just to the west. Even under the darkest skies, NGC 4284 is very difficult through a 5-inch and even larger telescopes. It's at magnitude 14.3. It's just a whisper. Well, folks, by God's grace, we can see these. So here's M40 or Winnicky 4, and this is NGC 4290, and that is 4284. So those are the two objects he puts as companions. So I'm just going to do here under M40, I'm going to say just a plain Mag 9 optical double. And then under 4290, which we've never observed before, I'm going to say we could make out the bar after just 8 minutes, along with some of the spiral trails. And then for 4284, do a quick observation there and say this was pretty much nothing more than a faint smudge for us after 10 minutes of integration. All right, let's catch up over here in the comments. Yeah, Dennis is pointing out that this M40 is just a Mag 9 star. Ray says, I think the stretch factor button is behind your phone icon. Oh. Stretch factor button. This icon? I don't see a stretch factor button. So Ray, you'll have to fill us in on that. Stu, you were with us. I didn't know you were there, brother. Why is Stu saying good night in New Zealand? He must be sleeping during the day. Oh, you were saying good night like hello. I see. So that must be a New Zealand thing. In New Zealand, you can say good night to greet people, I bet. I guess we can do that in the United States too. It just caught me off guard there. Normally, I think of good night meaning we're going to take leave and go to our bedroom. But I see here now, you meant for it to be greeting. Anyway, welcome, Stu. We're working through this Cosmic Challenge list, Stu, and maybe you've already picked up on the fact that we're getting used to Astro Planner, and we're looking at some of these tougher objects to view. So we've just focused in on this M40, bottom of the right side. And you're saying that's called the stretch factor button. Oh, are you talking about the reset color balance, or are you talking about this maybe? The reset here? Maybe that reset there is what you mean. I think. Maybe it was off, but I think. Oh, Stu, we're going to miss you. Why are you going to sleep in the middle of your daytime? Are you working nights now, Stu? Or you got to take off. So you said good night because you knew that we'd hear it from our perspective. But where you are there, it's good day, isn't it? I'm going to save a picture of this just so we've got one. But all right, back in the observing tab. You know, we did all that, and those are only at 18%. Let's sort the list again now. I don't understand this sort deal at all. Anyway, the next object would be, oh my goodness, that was quite a shift of things. But I don't know that it helped us that much. Here's something, NGC 1851, which is at 11 degrees altitude. I don't know if we'll be able to see that or not. Let's try it. Let's be adventurous. So here we go. Next image, next target. And slew to the object. This is NGC 1851. NGC 1851. Oops. Yeah, that's right. Dennis, little help here. What is a radio galaxy? Is the term self-explanatory? I think, Dennis, we normally use the term radio galaxy to describe a galaxy that doesn't show up visually. It's sort of like gone dark visually. It only shows up as a radio source, I think. Maybe it shows up in another band like infrared. But really, the truth is, you could use radio galaxy about any galaxy that can be observed in the radio spectrum, whether it's visible or not. And that's really a better meaning for the name radio galaxy. So any galaxy that we can detect in a radio telescope would be a radio galaxy, I think. Tiffany's saying, see you next time, Stu. Okay, I think our scope is settled. Let's go back to the screen and let's look for this 1851, and we'll go like this and say, oh, first let's queue up. Notice how in Stellarium we're pointed at Winnicky 4, those M40 double star objects. And now we're going to go right click on NGC 1851 and we're going to say center and Stellarium's field of view, and bam. There it's supposed to be. Uh-oh. That's not good. It's saying it's straight down. But Astroplanner's saying it's visible. What's going on, gang? Let's go back over to our scope and see what happened to our scope when it was slewing. It doesn't show it as pointing straight down. Maybe it stopped when it got to the horizon. Or maybe the roof wasn't open and it struck. Oh, I hope not. Surely not. Let's go find our mount control. Nope, tracking's still going. So see, we pulled up our iOptron Commander mount control panel and it says we're still tracking. Whew. So I don't know what's going on. Let's go to Stellarium here and let's go Control F3. NGC, what is this object again? 1851. 1851. Boy, Stellarium is convinced that it's out of view. Okay, who's right, who's wrong? Well, there sure is something pretty there in our field of view, isn't there? Looks like a globular cluster. Yeah, and that's what the object is supposed to be. So what's up with Stellarium? it's pointed straight down. Look, like it's looking through the floor of the observatory. And it also reports that the telescope is. Stellarium, what's going on? NGC 1851. Is that the correct object? Yeah. I'm lost. Yeah, just more gain in the scope cam. Yes, folks. It's a true night security cam. Stellarium shows it's still at 5 degrees here. Well, the time is right. Look, even up here it says NGC 1851. It says it's a globular. What in the world? I do not get that. It's like the coordinates for NGC 1851 are not correct in Stellarium. Well, let's just go to the live view because quite obviously this is it. It's actually a pretty good size glob, isn't it? How did this not make the Messier list? Somebody help me out here. Why wouldn't this have made the Messier list? It's beautiful. Let's go to the object number, which is 71. Oh, it's 40 degrees south of the celestial equator. As a result, it never crests more than 20 degrees above the southern horizon in most of North America. Our southern hemisphere colleagues remark that they easily see NGC 1851 through a pair of binoculars, and that it's a showpiece for the January and February skies. Our view, however, is hampered by horizon-hugging haze and light pollution. The result is merely a dim glimmer of the globular's true self. Star-like central core resembles the coma of a tailless comet. But if you increase the magnification, the illusion starts to change. The comet takes on the graininess as if on the brink of resolution. Thirteenth magnitude stars around its fringe. Man, I think it's beautiful. It's got a distinct Christmassy look, doesn't it? Snowball, greenish snow cone, lime. It's a lemon-lime snow cone snowball. This 13th mag glob was an easy target for our 11-inch Harrington writes that what makes it tough is its low to the horizon location. It looked to us like a lemon lime snow cone snowball. Frozen Sprite, Jesse says, right? Boy, for some reason, there we go. All right, back to the object list. I don't know if you have to go back to this object list each time or not. Maybe you can keep doing it from... Anyway, there is our observation. Now, we've seen the Horsehead Nebula, but IC434, let's go here anyway. It's plenty high enough. Wonder what 434 is. Look how in Astro Planner, let me bring this over so you can see. I don't know if you can see over here in this little, what would this be called? Like your stock image of this object. But this little red hairline sight thing changes. So that's Barnard 33, so that's the dark nebula. And then this is IC434, which is the, I guess, the regular nebula. So he's pointing out that the dark nebula is in front of IC434. So this entire patch of gas would be IC434, and the Horsehead Nebula is B33. So I like that little red crosshair because it sort of points out what each thing is as you click back and forth. All right. Let's go to Barnard 33. Boy, this one is just easier to find up here. Now we can tell when the slewing is done because that green bar graph. Let's see if Stellarium straightens out on this. Center in Stellarium's field of view. Stellarium is just broken. So I have a hunch that I must have hit say I must have hit something like sync to object or something. I think what we should do is close Stellarium and then try to reopen it, see if that fixes it. because I don't know how else to fix it. I wonder what is that little thing? Set time to now. Set normal time rate. Center in stellarium's field of view. B33. What is going wrong with stellarium? B33. I'm just going to close it. It's not working. Goodbye, stellarium. Okay. Meanwhile, back at the ranch, Dennis says that Barnard 33 is one of his favorite nebulae. Oh, this doesn't look like much yet. We're going to reset the display histogram here on the side. And then we're going to reset the stacking histogram and do a color balance. Boy, that helped things a lot already, didn't it? Wow. Can you believe that's after 60 seconds? Wow. Look at that. Wow. 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 100 seconds. Now this is that flame nebula. So this is Barnard 33, and this in back of it is the IC434, this red cloud bank. So what we have here is a chess piece silhouetted in the night sky because those dark gases are spewing up in front of that red snowbank of IC434 behind it. Well, I will never cease to be amazed when this pops into our field of view. How about you? 2 minutes and 40 seconds. You can see some other little dark nebulae here, kind of spewing up into that snowbank as well. And Tiffany says, holy wowza. When you back off and get the whole picture, it's just even more gorgeous because you get the full view of the flame nebula. Let's try stellarium again now. See if we can get it sorted out. I might have hit a button by mistake that kind of like, what would you call it, like skewed stellarium's alignment with the sky, maybe, because I could have very well. Love that the flame nebula's in there too. Jesse, outstanding. The location is correct, Dennis, in stellarium. But obviously somehow it got skewed. All right, we're going to say, show us please B33. Yeah, we're fixed. So I must have hit a button that skewed things. Okay, so this is apparently, what is this nebula called? I forget. Lump star? I think it's just called Lump Star Nebula. That's IC434. This is B33, and this whole thing is IC434. Flame Nebula is NGC 2024. And as you can see, this is actually the star that we see that's so bright in this image is Alnitak, the third star in the belt of Orion. And the second star we're seeing along with it I don't think it's Al-Nilam, is it? Let's put on our field of view here. No, it's not. So this is Alnitak. And I guess that's the lump star. .48 Orion, but there's no nickname. We should name that star tonight. Wow, it's really beautiful, isn't it? Helps to tune that sky a little bit darker, doesn't it? And then keep the reds pretty high. Wow. Boy, thank you, Lord, for making such a beautiful part of the sky, huh? I think this is one reason why I like the RASA 11, because just by nature of the way the RASA is, this is an easy view. In fact, we can back out some. You know, it's just gorgeous. And it's showing us all these tendrils down here of that hydrogen 2 region. It's really coming out now. This is just 8 minutes of integration. Boy, what do you say about the horse head, though? I mean, what do we say in our observation notes? I mean, it looks like some great chess game in the sky, doesn't it? And IC434 just looks like to me like a red snowbank. A snowbank that's been illuminated by a red light, huh? Ray says it's my favorite objects to image. No wonder, Ray. It's a beautiful view of this lump star. What's the designator of that lump star? NGC 2023. NGC 2023. First time to observe that, I think. How would you describe this? Blue-green companion that kind of looks a little bit out of place. I hate to say that, next to the horse head. I mean, right? It's just a little bit. But maybe it just adds to the Christmassy look. Ray says you should see this with a mono camera and an HA filter, I bet. Books, I went to a dark sky site and imaged the horse head a couple of weeks ago. My backyard skies are way too bright for my setup. Dennis, I'd love to shoot it with a mono ray, but right now I'm using an OSC one-shot color. Wow, look at just the depth of the colors of that flame nebula. It almost looks like that can't be up in the sky, can it? I mean, isn't that right? You just sort of look at it and you say, whoa, is that really up there? So a good way to find this is to look at the left star of the belt. And you'll know that that flame nebula is right there being lit up by Alnitak. And then just drop down a little bit toward the sword, and you'll know the horse head is right there. All right. Well, we're in our last 15 minutes here. Let's make tracks and catch something that's more challenging. Now that I've got these Cosmic Challenge levels typed into this list, I can see whether or not it's meant for naked eye, binoculars, 3 to 5 inch scope, 6 to 9 inch scope, 10 to 14 inch scope, or monster scope. It's now we can see which is which. So let's go to something like let me sort to make sure. Boy, I still don't understand the way the sort works. Yeah, it did change the list, didn't it? Let's find something really challenging to end up with. How about looking for something like maybe in the monster scope category. So let's just skate down here toward the end till we get to the 15-inch and larger scopes. And let's just try a dare of one. 15-inch and larger. How about this set of galaxies? IC2388. IC2388. So let's slew there. IC2388. Joe is asking, are you going to make your list available on the user-contributed list in AstroPlanner? Yes, we've already told Paul that we'll do that. I kind of wanted to see how it worked and see if there's anything that we ought to tweak. But what we did that I don't think has been done before in any targeting list of the Cosmic Challenge is we've put in all of the member galaxies of each group. So in other words, if you look here on the screen, these groups that are bracketed together, like this is all object 157 for him. This is group 157. And I don't think there's a single place on the web where you can find this this list. And so yes, by all means, Joe, that'll be in AstroPlanner. I think Paul is imminent on releasing this next version, and it'll let us, at f2.2, it makes up for the larger scope. Well, let's hope so. Hopefully it'll let us merge in all our observations. But yeah, I'll go ahead and upload this right away. Joe, thanks for asking. Tiffany's suggesting we all go to Ray's house for a star party. I think that's a great idea. Boaks picked up Andromeda. From where you are, that's pretty miraculous, Boaks. Because you're in, I think you're in like somewhere in Australia, right? Okay, so this is IC2388 and the group, that's 157. So he names this Galaxies Beyond M44. That's kind of his group name for this. Galaxies Beyond M44. Melbourne. Yeah. That's incredible that you were able to pick up the Andromeda Galaxy. Yeah, this is definitely more challenging, huh? Because at this point, we're not seeing anything but stars. And this is already after plate solving. IC2388. So now we'll try this again and see if we can make this work. Center in Stellarium's field of view. That's the right choice to make, right? I'm not messing that up, am I? Center in Stellarium's field of view. Oh boy. See that? That's messed up again. It did it again. So something's not right about the connection to Stellarium. I'm just going to stop using that right-click menu for right now because it's obviously not working. This shows to be at 40 degrees above the horizon. Boy, I'm not seeing any galaxies in that view at all. I hope we didn't overestimate our abilities here. I was assuming that with EAA, with 11-inch scope, we could see what a 15-inch scope would normally see, but I am not seeing anything in that field of view. But that's the way it should be. We should challenge ourselves, right? That's what we're supposed to do. I see 2388. Okay, so we're going to go F3 for the search. I see 2388. Yeah, it's up in the sky. Wow. So, we're evidently looking through the Beehive cluster. Now, where is M44 then? M44. Oh, the Beehive cluster is M44. Okay, so this cluster that we're seeing here is M44, or the Beehive cluster. And what he's saying is there are galaxies visible in this frame somewhere. Yeah, you guys got Eta Carina, Running Chicken, good view of the Milky Way. Ray's saying crank up the gain, but man, Ray, I just have this. Okay, here goes. 350, Ray says. Do you have the same camera though, Ray? Do you have the 2600? Drum roll, drum roll, drum roll. Folks has got to go. Thank you, folks, for being here. We're just 5 minutes from closing out, so you didn't miss anything, folks. Thanks for being with us. Okay, so we're at 350. Let's try to find some of these galaxies. Oh yeah, there are some named here, so let's see if we can find some. So first, let's look at NGC 2624. NGC 2624. So it's that one. Boy, it's just going to look like, I mean, it's just going to look like a star. Tell you what, let's do. Let's go back here. And let's turn on Deep Sky Image Annotation. Several of them noted there. I wonder if it's trustworthy enough. Before we turn that on, let's solve one more time without syncing. I wonder if we zoom in on these. Oh, it's not letting us zoom because it's in the middle of... There we go. It was latency there on the zooming because it was in the middle of solving that frame. Oh, so you do have the 2600. So you have the exact same setup, 2600 with the RASA 11. And more experience. So see, that's why I listen to you, but man, I just, there we go. 350, there you go. Okay, so we are plate solved now, and let's turn on deep sky image annotation. Now these crosshairs should be like spot on. I mean, like literally, they are dead on. So let's go through and catch some of these. 2624 is right here. Would we have ever noticed that? I don't know if we would have or not. I guess we would have, wouldn't we? Eventually? Look how tiny it is. It just looks like a splotchy star. So there's 2624. Check. 2625. Check. Where is 2637? So small. That's, oh, here it is. 2637 is down here. My goodness. Look how faint that is. Wonder what magnitude that is. What magnitude is that? Well, it says 15.4. I guess we're at 8 minutes, but wow. I guess it's 15.4. But that's going to be different than a star that is 15.4. Because remember, when it's a galaxy, it's spread across the entire splotch. So the magnitude gets diluted. Dennis has got snow. Tiffany, we originally had planned on that, and if it's clear, yes, we will. Thanks for asking. So 2637. So Tiffany was asking if we're gonna try to observe on Thursday night as well. We are. If it's clear, we'll be here. 2637. Now what about 2643? Boy, isn't deep sky image annotation helpful? Keep in mind, this is a live view of the night sky. And then our imaging software, SharpCap, is overlaying these crosshairs so we can find the stars real time in the actual image that we're observing real time. So there's 2643 down here. Check. They do look a little bit different in color, don't they? Notice how the stars are just a bright white, and these galaxies are almost greenish, aren't they? 2647. 2647 is right here. Check. 4526 is a UGC number. So I doubt if that'll be in our deep sky image annotation. And then Zwicky 8956 is not going to be here. But some of these are Hipparchus numbers. I guess they're just pointing out the star so that we can use them as guide stars for the finding the other galaxies. But this is, I guess, a good example of a faint galaxy cluster. Oh, I see one here. I wonder if he's got a... He does. He has a nice detailed map. So let's look for... Let's get our bearings here. (2643) 2637. IC2388 there. Yes, colorful stars is right, Ray. I see 2388. So what are we looking for? We're looking for CGC 89-068. CGC 89-068. Otherwise known as NGC 2647. Okay, we already saw that. So now we're looking for UGC 4526. Oh, here it is. So it should be down here. Oh, that's the spiral we saw. This spiral. This is UGC 4526. It sort of leaped out to us. There's some latency because of all. I'm not zooming in anymore, but there's latency. I need to be a little more patient. Because of all that deep sky image annotation, it's got a lot to recalculate every time. So anyway, that's this UGC 4526, and then Zwicky 8956, ZW 8956, otherwise known as CGC 8956, and 8962. Should be up in here somewhere. Right around in here. See this pointer? See how this kind of makes a shape of an iron? I think that's called the beehive. See, that's why they call it the beehive cluster. It looks like a beehive, huh? And that pointer points directly to 8962 in this area somewhere. Let's zoom in on that area. See if we see any smudges. Yeah, right there. Boy, that would have been hard to find without a map. Wouldn't it? Just a faint splotch. And then the last one, CGC 8962. Oh, that's 8962 and 56. Is here. Look at this splotch. Almost looks like they're, let's go ahead and turn off deep sky image annotation now. It's not helping us because of all that. Right here, look at this. Look at this splotch here. That's CGC 8956. All right, so that's where we needed to end because it's the biggest challenge. It's for a 15-inch scope. But again, the reason we can do these is because of the electronically assisted astronomy approach, laying frames on top one another. And Ray is kind of, chiding me saying, see, the gain worked. And you're right, Ray. So I'll learn this. Well, thank you guys for being here tonight. This has been a lot of fun, and we've tried out a brand new observing program. I think we still have a lot to learn about it and how it ties together with deep sky, with Stellarium, how we tie together the astroplanner with Stellarium. And I'll do some work on that to try to figure out why they were messing each other up, I love this spectrum of objects we saw. We started out, remember, with looking at the Great Square of Pegasus. Naked eye, just looking at Ursa Minor, the Little Dipper, and then we went to 3-inch scope items and then 6-inch and just worked our way up until we now got to 15-inch scope and up. Monster scope challenges that are possible with EAA. And all from within a shirt sleeve environment here, 72 degrees, and outside it's 30. So I just have really had a good time, and I hope you enjoy this kind of content. If you do, don't forget to subscribe. If you like this, click a thumbs up or like or whatever you call it. If you want to be notified when we're going to do these, you can hit that bell. And the night before the broadcast, we'll do a community notice. So you'll be alerted if you've got that bell clicked. Another thing you can do is go to emeraldhillskies.com, and on any of those pages at the bottom, I think it is, you can sign up in a little quick form, and that puts you on an email list at whatever email you want to use, and you're not solicited or spammed at all. It's just a notification list for when we're going to do these. And we do those at the same time, just that some people don't see the YouTube notices, so this gives them an alternative way they can be notified by email as well. One more time, we just want to say thanks to God for making these great objects for us to see, for putting them so far away, and to Phil Harrington's book, Cosmic Challenges, or Cosmic Challenge rather, because it gives us a catalog of objects to see. We'll be uploading this to AstroPlanner as a user-defined list, and we'll keep trying to learn more about AstroPlanner in the days that come. Hope to see you back Thursday night if it's clear. If not, we'll just come back in the next clear night. Thanks again to all of our gang, Tiff and the crew. Ray's pointing out it only works on the hard to see objects. Too much for most of them. I agree. The 350 gain would be too much for most. Thank you for pointing it out. And Ray says M44 is too low in his sky due to the house being in the way. So, well, God bless you guys. Thanks again for being here. It's a lot more fun since astronomy is not a solo sport anymore out in the cold where you hear bumps in the night. It's a team sport, and you guys are part of the team. God bless. We'll look forward to seeing you next time. Take care. Good night.